Hello viewers, you're welcome once again. We are still under logic. Christ Almighty God's Algebra. In our last tutorial, we treated law of identity by conjunctive statement. Today we are going to treat law of identity by disjunctive statement. Let us start. Law of identity. P or F is equal to P. This is a typical example of law of identity by disjunctive statement. Why do we call it law of identity by disjunctive statement? It's because of this or connective that combines P and F as a compound statement. So, by the reason of this connective that combines P and the F together as a compound statement, it is called conjunctive statement. So it is called disjunctive statement. So we say that it is law of identity by disjunctive statement. Let's prove the statement that P or F is equal to P. Prove suppose P or F is equal to P. We are assuming that the statement is true, that P or F, that means falsity, is equal to P. And if you look at the statement, you will find out that it is logical equivalent. That means it is law. Because whenever the left hand side of the equation is true, also the right hand side of the equation is also true. In the same vein, whenever the right hand side of the equation is false, also the left hand side equation is also false. You see, it's logical equivalence. Since it is logical equivalent, we can transform it to biproportional statement and it will still preserve logical equivalent. If and only if P or F, if and only if P, you have now transformed it to biproportional statement that P or F, if and only if P or F, P or F, if and only if P. You have now transformed it to biconditional statement. And you find that whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. So if you want to read the statement, the possibility of getting falsity always truth. This statement is tautology. Since whenever I read the statement, the possibility of getting falsity in any of relation always truth. You say that the statement is tautology. Is tautology being justified by logical equivalent. Being justified by logical equivalent. Now, since P or F, if and only if P is tautology, that means the biconditional statement is tautology. We can also transform it to conditional statement and it will still preserve tautology. That is, if and only if P or F implies P. You see that whenever the antecedent is true, also the consequent must also be true. Therefore, if you want to read this statement, there's no calculating falsity in any evaluation, always truth. Since we always evaluate it to be truth, we say that statement is tautology. Is tautology. Statement is tautology. Being justified by logical implication. Being justified by logical implication. If and only if you see that this P or F is a proper implication of this P, that is, the antecedent is proper implication of the consequence. So if that is the case, we then deduce that it is certain that P or F exists. That it's certain that the antecedent exists. So if it's certain that P or F exists, we say that P or F is logical implication of P. P or F is logical implication of P. So it's logical implication of P. Since this P or F logical implication of P is true, also this must also be true. If and only if P or F is equal to P or F. That means the logical implication is equal to itself and is logical equivalent. It says that whenever the left side of the equation, that means P or F, is true, also the right side of the equation also that means P or F is also true. Instead, whenever the right side of the equation is false, also the left side of the equation is also false. You say that it is logical equivalent. So it is true that P or F is equal to P or F. Being justified by identity, that means the sameness. Being justified by identity. If and only if P or F is equal to P or bracket not P and the P. You have seen that we have just stated F, this F with not P and the P. So this F is equal to not P and P by law of complement. Not P and P is equal to F. So F is being substituted with not P and the P. Being justified by law of complement. If and only if P or F is equal to P or P, you will see that this P or bracket not P and P is equal to P and the P, P or P by second Ejike's law. So by second Ejike's law, P or bracket, not P and P is equal to P or P. That's why student P or P, student P or bracket, not P and P with P or P. Being justified by second Ejike's law. If and only if P or F is equal to P. You know that P or P is equal to P by law of idempotent. By law of idempotent, P or P is equal to P. So we substitute P or P with P. Being justified by law of idempotent. We have now proved that P or F is equal to P. We are proving that P or F is equal to P. We then conclude. Say thus P or F is equal to P. Having proved that P or F is equal to P, and the statement is logical equivalent, that it is law, we are going to prove the converse. So by the principle of externality, we then establish that P or F is equal to P is law of identity by disjunctive statement. Let's prove the converse. Conversely, P is equal to P or F. You see that this P or F at the right side equation here has now become P or F at the right side equation here. Then P at the right side equation here has now become P at the left side equation here. You say that it is converse. Let's prove the statement P is equal to P or F. So suppose P is equal to P or F. If you look at this equation, is logical equivalent. That whenever the left side equation is true, also the right equation is also true. Whenever the right equation is false, also the left equation is also false. You see, it's logical equivalent. Since it's logical equivalent, we can also transform it to biconditional statement. That is, if and only if P or F. You have now transformed it to biconditional statement. I know that whenever the left equivalent is true, also the right equivalent must also be true. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So whenever you want to make this statement, that means you are getting positive, always truth. The second statement is tautology. Is tautology. Being justified by logical equivalent. Being justified by logical equivalent. If and only if, now this statement is tautology, that this by statement is tautology, then you can also transform it to conditional statement and it will still preserve tautology. That is, P implies P or F. You have now transform it to conditional statement. I see that whenever the antecedent is true, also the consequent is also true. So whenever you want to use this statement, that was you're getting positive, always true. So that statement is tautology. Is tautology being justified by logical implication. Being justified by logical implication. Now, since this statement is tautology, P implies P or F tautology. We then deduce that it is certain that P exists because P is proper implication of P or F, and means the antecedent is proper implication of the consequent. Now, since it's not certain that P exists, we then say that P is logical implication of P or F. That means the antecedent is logical implication of the consequent. If and only if P is logical implication of P or F. That means P is logical implication of P or F. If this is true, that P is logical implication of P or F, also this must also be true. Let's continue this side. If and only if P is equal to P. That means the logical implication P is equal to itself. That means it's logical equivalent that P is equal to P. In the sense that whenever the left hand side of P is true, also the right side of P is also true. In the same vein, whenever the right side of P is false, also the left side of P is also false. We say it is logical equivalent. So it is true that P is equal to P, it's logical equivalent. Being justified by identity. That means the sameness. By identity. If and only if P is equal to P or P. This P is equal to P or P by law of idempotent. So by law of idempotent, P is equal to P or P. That's why we substitute this P with P or P. Being justified by law of idempotent. If and only if P is equal to P or bracket not P and the P. So this P or P is equal to P or bracket not P and the P. By second education law, P or P is equal to P or bracket not P and the P. That's why you should state P or P with P or bracket not P and the P, being justified by second education law. Second education law. If and only if P is equal to P or see that this not P and the P is equal to F, being justified by law of complement. Is equal to F, being justified by law of complement. Now you have now proved the converse, that means P is equal to P or F. That means P is equal to P or F. Having proved the converse, we then conclude, say thus P is equal to P or F. Having proved the converse by the principle of essentiality, we then establish that P or F is equal to P is law of identity by disjunctive statement. Therefore, P or F is equal to P. We have now proved that P or F is equal to P is law of identity by disjunctive statement. That means P or F is equal to P exists as law of identity by disjunctive statement. At this junction, we will draw our curtain. Thank you, viewers.